with the structural system that you want to use. Do you want to decouple your lateral system and gravity system? You can do that in performance-based design. You want to have a spine which is outside the building, you can do that in your performance-based design. You cannot do that in code-based system. Performance-based design requires designers to kind of be more forefront in education and assess the building performance in extreme events, right? How do you assess the building performance? There are numerical methods, there are experimental methods. Experimental methods are costly, but you need those experimental methods to calibrate your numerical models so that your numerical models are robust enough to predict those experimental events whenever that happens. So again, it's a chicken and egg situation where, yes, experiments are costly. Numerical methods, if you know the modeling, are much more cost and time effective, but you need data, experimental data, to calibrate and validate those models before you can use it. And performance-based design arguably can produce safer and more cost-effective solutions. Initially, the cost is a little bit higher because it's a new concept. With any newer concept, costs are generally higher, associated with a lot of other things rather than a lot of policy education, a lot of construction education, rather than just designing the building itself. So once those things are standardized, your building would automatically become economical in that sense. So one of the key factors that happened during the earthquake was the time to functionality was very high, right? So the owners and the stakeholders began questioning the building performance of a code-based, code-compliant building in the wake of few of these earthquakes and a few of these high-speed wind events. So why are our buildings, okay, they're not falling apart, but we cannot go in the building for about a year after the event? Why is our building performance lacking our expectations? So they started to question that. And then owners, the building owners, the developers, they also express some desires in terms of expectations for performance objectives. For example, the building should be safe during an earthquake so that people can go out and be safe, come out in the open. And then some owners said building needs to be reoccupied right after a major event. Some said building should be reoccupied right in 2 weeks or 2 months after a major event. Some building owners can prescribe that no non-structural damage should be there for up to 2% of building drift. And some owners can prescribe repair costs should be less than 25% or 20% or 15% of the replacement value of the building. So these are what we call performance objectives. So when you can design for all or any of those objectives. And that is what performance-based design inherently means. You're designing for a performance objective. And who decides the performance objective? It's the stakeholders. We'll probably talk about that right after this or maybe after lunch as to how stakeholders are coming together to define those performance objectives. And since it's not in the building code, you can have any or all of the performance objectives and many more, whichever you can think of. So performance-based design is an approach in which the structural design criteria are expressed in terms of these performance objectives. So performance objective generally has 2 different components, and we'll talk about that. One is the performance metric itself. For example, 2% drift. But 2% drift of the building in what? 2% drift during a 3.0 Richter scale earthquake? Or a 2% drift for a 100-year return period earthquake? or a 2% drift for a 500-year period earthquake. So there's a performance metric and there's a hazard level combined together in the performance metric, in the performance objective. So performance-based design is based on performance objective, where we are designing the building to achieve those performance objectives. Performance is directly linked to design, and there is a performance check. Again, that check could be numerical or experimental, or a combination. And then we ensure that the structure reaches specified demands level, both in service and strength design levels during the design. Questions? Okay. So comparison between prescriptive and performance, right? If your approach is code-based, the emphasis is on procedure. It specifies what to do and how to do it. Your typical building code does it. The outcome is implicit expectation and no performance checks. But if it's a performance-based approach, the emphasis is on key performance indicators while ensuring safety of the elements. So what approach or what procedure do you take? Within certain bounds, you can use whatever you like in terms of your design methods, in terms of your design philosophy, but the idea is to achieve the performance objective. And it requires a lot of trial and error, a lot of iterations. The outcome is there are explicit performance check. You know that at a 50-year return period earthquake, maybe through modeling, maybe through simulations, that your beam or your building is not going to deflect more than 2%. Your interstory drift is not going to be whatever you prescribe it to be. And that could be numerical or experimental validation, or a combination of both. Sound scary? How would you do it? So I talked about it a little bit, but let's explain it in much more detail. Performance objective has two different levels, right? One is what is your performance level and what is your hazard level associated with it. So let's say you have a ground motion. This is an actual record of a ground motion. This has an X% probability of exceedance in 50 years. So X could be 2%, 10%, 20%, 40%. So the lower the percentage, is the ground motion more severe or less severe? If I say I have a 2% probability of exceedance in the next 50 years, is it a very severe ground motion or a less severe ground motion than very severe? So the lower the probability, severe is the ground motion. In that ground motion exceedance criteria, my performance level should be something that I decide. So let's say the maximum acceptable damage given the ground motion occurs should have a residual drift of 2% or a residual drift of 1% after the earthquake. Or my plastic rotation should be 2%. That is something you decide. So you have a hazard level, you have a performance level that defines your performance objective. These are not mutually exclusive. Your performance objective has to have a hazard level and a performance level. And the performance level could be, let's say, in 1%, with a 1% probability of exceedance in 50 years, my building should be collapse preventive. It should not collapse, and I don't care about what happens next. All the people should be safe, they should get out in time. I don't want functionality, I don't want anything. That could be a very valid performance objective. Your performance objective also could be 2% exceedance level. In 50 years, I want a totally functional building after the earthquake. Should be designed for immediate occupancy. And that will govern your drift levels that you design. Does that make sense? So during an earthquake, and it could have different performance level based on hazards, right? Let's say you have base shear versus structural displacement or residual structural displacement diagram. Your initial fully operational building will be somewhat designed on a linear level. Then as it yields and it forms kind of reaches capacity, it moves into the operational level, life safety realm of your performance objective towards a massively high displacement. You can probably design for collapse prevention. But these are general areas where you need to be in terms of your base shear versus structural displacement and what does fully operational life safety, LS or collapse prevention building means. Just to give you a glimpse of resilience, and how performance-based design is linked to resilience is, let's say I have this towards the right, I have a matrix. I have a matrix of earthquake design levels, which is very rare, occasional, frequent, right? And my performance levels, which is operational, immediate occupancy, life safety, and collapse prevention. Operational building is like a building designed to be operational for right away. Immediate occupancy, maybe a little bit of downtime, but within a matter of weeks, you can occupy this. Life safety is, a lot of repair is needed, but all lives were saved. Collapse prevention, again, the building is not collapsing, but it has to be torn down after the earthquake, right? So as you go along the matrix, so for frequent earthquakes are very low-level earthquake, right? In a high seismic zone, the ground's vibrating a lot of times during the day or during the month. Very frequent earthquake, you want your buildings to be operational mostly all the time. Some occasional earthquake, your performance level can be immediate occupancy. And this is what I'm talking about, the code-based levels right now. For some rare earthquakes, you want life safety, and that's what your code recommends, is life safety for rare earthquakes. For very rare earthquakes, 2% in 100 years or 1% in 50 years or more, you want collapse prevention, right? And as you go from operational to collapse prevention, your repair cost increases, your downtime increases. Now, these are code-based guidelines for now, but I can be creative and say I reject those basic objectives and I can improvise and say I want a little bit more from the design codes. Our traditional design standards or codes generally focus on life safety and collapse prevention for rare and very rare earthquakes. But we can also use enhanced objective where we would fall under these areas or these boxes which are shown in colored. For example, we can say for a rare earthquake, I can design for immediate occupancy level, and for a very rare earthquake, I can design for a life safety level. These are enhanced objective, and that will require performance-based design. Or I can take it one step further and say for very rare earthquake, I want immediate occupancy as well. And for occasional earthquake, I want totally operational. So these are again enhanced objective. You can go to the other side as well, but then that won't be code-based at all, so it's illegal building at that point. Questions? and maybe point me if I'm wrong, Shrimali sir, these will all be available, the slides will be available to them online? Or the slides will be available to them? Okay. So yeah, the slides will be all be available to you. Sure, sir. So when you're designing for these enhanced objectives, you're using performance-based design. There are many variants of performance-based design. And again, based on performance objectives. There's displacement-based design. There are yield point spectra method design, capacity-based design, direct displacement-based design, and unified design method. Direct displacement-based design is one of the more popular ones. It has gained a lot of popularity over the years. It was developed by a scientist called Priestley in New Zealand and then in San Diego. They did a lot of work on concrete, started with concrete, then also came into timber. Unified design method, and maybe some of you know, Professor Chaudhary from NIT Silchar, Satyabrata Chaudhary. He pioneered the unified design method, where he took displacement-based design method one step further, and during his PhD and also while guiding other people's PhD, he coined the unified design method. We'll talk about these two in much more detail over the course of the week, but there are many more variants of PBD or performance-based design that you can use. These are some of the most common ones. Does this ring a bell? Capacity-based design, what does this mean, do you think? We will use capacity-based design also in direct displacement-based design, because every other member is capacity-based. What does the philosophy of capacity-based design mean? Anybody? When you're designing a member, what resistance are you using? What properties are you using for the material? Characteristic strength or expected strength? Characteristic strength, which is factored down, right? So in capacity-based method, you're using expected strength for most of the materials. So the idea is, for capacity-based design, the idea is you define your failure points. Let's say my beam column, this beam column junction will fail, right? You design that for failure or yielding. Everything else, you stiff the heck out of it so that nothing fails by using capacity-based design. So you're guiding your failure to that one point that you can control better. Does that make sense? So before, I had planned that I will jump right into direct displacement-based design, but maybe before doing that, maybe let's talk about how performance objective and how stakeholder involvement is there in performance objective. And then maybe after the lunch break, we can talk about, it'll be a lot of theory in terms of displacement-based design, but then we will probably end the day with a numerical example for displacement-based design. I'll give you the steps. And I have an Excel spreadsheet prepared for you to take if you want. That you can use for displacement-based design for concrete structures. Let me change the So selection of performance criteria levels or performance objective in general. how do we do it and who are involved? Is it just the engineer saying that we want to design for 2% drift, 4% drift at certain level of hazards, or it's a much more communal discussion, much more brainstorming that needs to happen? So performance objective, just to define what performance objectives are. Performance objectives are goals that need to be met. And these performance criteria are quantifiable structural responses that leads to performance objective. What does quantifiable structural responses mean?
Displacement first.
Displacement for sure. So, any example? Drift. Are there any other quantifiable structural responses apart from displacement? Strains, forces, stresses, anything is a quantifiable structural. As long as you can quantify it, they are responses that are structural. In general, as we are talking more about displacement, displacements are much more used in performance-based design as quantifiable structural response, and those leads to performance objective. Like one of a typical performance objective for tall building initiative in the US is, after MCE, do you know the difference between DE, SLE, MCE? Maximum considered earthquake? You know what it is? How is it defined in the Indian code? Return period of 2475. So before that, there are two different hazard levels: service level and design level. MCE is kind of the highest, right? And there's a new term called MCER. So after MCE, after the MCE level earthquake, a tall building should have a residual drift of 1%. So after the earthquake, if the building is tilted, it should not be tilted more than 1%. That's one of the performance objectives that the Tall Building Initiative is really pushing in the US for resilient and functional recovery-based buildings. But that is a very stringent requirement because residual drifts of 1% after an MCE, it's a very, very costly design. So again, your design objective or your performance objective could be you're designing to 2% drift, 3% drift, or maybe 4% drift with certain damage, 3% drift with no damage, so on. So our performance level indicate damage state of an element or a structure, right? And then there are three widely recognized performance levels, which is immediate occupancy, life safety, and collapse prevention. You probably know that from the building codes. I'm not redefining them, but these are the three performance levels, which has an associated hazard level based on it. So key factors in coming up with those performance objectives. One is what type of building it is, what it is going to be used for. Is it a school? Is it a residential structure? Is it single family house? Is it a multi-family house? You should not be doing a performance-based design for a single family house. It's just too costly and there's no need for that. Your building codes are good enough. But if it's a multi-family house, like an apartment complex, like the condos in Hyderabad or Bangalore, which large complexes, you can probably do a performance-based design. If it's a school, hospital, other government buildings, probably you can consider performance-based design, and because those buildings needs to be functional during certain hazards. Then you do a hazard and risk assessment, right? Is it on a fault line? Is it in an earthquake zone? Which zone in your zone maps, zone 2, 3, 4, which zones are that building located in? What is the proximity to the coast? Is there a tsunami warning? Is it on a subduction zone? Depending on that, you can decide your hazard level and do a risk assessment. Are there any other environmental stresses, right? So if it's on the coast, you have, and it's near a fault line, you have earthquake, then you also have to worry about tsunami, so it's a multi-hazard decision process. What are the codes and other regulatory bodies, right? Some buildings, let's say, if it's in India, if you're building something for the British Embassy, then you have to follow the British codes along with the Indian codes. Same with the US Embassy. So there are other code and other regulatory requirements that you need to follow. And then stakeholders and community needs, that's the big one. Is performance objective is not just defined by you as a designer or the government agency or the government body. Performance objectives are collectively defined and agreed upon before you start designing the process. So other key factors that leads to those performance objectives is what material are you using, right? Is this a new material or a structural system that's not in the code? Then you have to take a performance-based design approach if it's not in the code, right? And the life cycle consideration. Is this material something that has to be replaced every 20 years? Or it can last for 80 years or 90 years? And that decision for costing has to come in terms of decision-making process. Sustainability and energy performance also impacts your decision-making in terms of your performance objectives. So stakeholder involvements. Who are the stakeholders? Stakeholders can be pretty much anybody, right? Developers and owners, they are the first people that comes to mind. Who is going to own the building? Who is developing the building? And developing for what? Users and occupants, or anybody who interacts with the building, right? You're living in the building, you're working in the building, you're occupying the building, you're a user and occupant. Or even there are some businesses that are housed in the building temporarily, or somebody that comes in and out of the building on a daily basis, maybe a mail person or somebody. Again, they can have a say if you want to involve them, but users and occupants generally are involved in those decision-making process. Government and policymakers, so your code regulatory body, your BIS, Bureau of Indian Standards, various other committees, academic committees, and so on. I'll throw the floor for question is, who others can be stakeholders? Designers, architects, yeah. Who else?
Academicians.
Sure. How can we forget them? The academic community, the research community, sure. Anybody else you can think of? We'll come back to that as we can keep thinking about it, and then we can populate that list as we go along. So you define your project goals. What are the steps involved in getting to performance objective? You define your project goals, identify the intended function and critical needs for that project, and then you establish your priorities. What are your priorities in terms of your project that needs to be fulfilled, and then you can come up with your performance objective. Then, of course, you know where the site is. You have to conduct the site hazard analysis. You get your geotech folks involved, get all the mapping done, evaluate potential failure modes and consequences. then these two inform you to set those performance criteria and objective, depending on what kind of building it is, where it is, what failure types are considered, what are your performance, what are your intended function, and then you do a qualitative and quantitative set of performance criteria and objective study, and you also align with your regulatory body, because you have to get them involved, otherwise they're not going to draw the building permits for construction for your project to go along. So it has to, your thinking has to align with them, and you have to convince them what you're doing is safe and code-based. Not code-based, but within the realms of design possibilities. Then you develop and design strategies and analysis procedure. That involves your design strategy. So what strategies are you using for design? What is your lateral system looks like? What your gravity system looks like? How are they interacting? You're using analytical and numerical modeling to define or to inform your design, also inform your performance predictions, and also you're considering not only earthquake, but multiple hazard scenarios, right? Wind, tsunami, those kind of things. Fire is a big one, which almost often define what designs are you taking. Then you iterate and optimize the design. That's pretty much it for now, but let's come back to who are the stakeholders. So owners, developers, right? Users and occupants, the policy folks, education folks, the teachers and the academics, the researchers. Who else could be involved in? What about contractors? Because they have to build it. What about people from the materials industry, which the materials build? Maybe it's a high ultra performance concrete that you're using or trying to use. High strength, let's see. Or some other kind of rebar. A titanium rebar is pretty common in the Western world these days. What else?
Industry.
Industry for sure. Pretty much anybody can be a stakeholder if they have some involvement in the building process. So, and it depends on the core team to whom to involve and what kind of performance objective comes into picture. So I guess it's a good time to take a break, and I'm here for any questions you have. Please speak up or come to me and we can chat. And then I think we're coming back here at 2 or 2:30. Shivali sir, what time are we coming back here? 2:15? 2:15 we should be back. Any questions?